In this video, we're going to determine the domain and the range from a graph. Before we discuss how to determine the domain and range from a graph, let's first recall the definition of domain and range. Remember, the domain is just a list of all the allowed x values or inputs. And the range is just all of the outputs that result from plugging in those inputs. Another way to say that is that the domain of a function is just a list of all the x values, and the range is just a list of all the y values. So how do we relate the definitions of domain and range to the graph of functions? To determine the domain from a graph, we describe every x value that the graph touches. In other words, if our graph touches an x value, then that x value is allowed and should be included in the domain. Same for the range. To determine the range from a graph, we will describe every y value or output that is touched by the graph. So in other words, if our graph touches a y value, then that y value should be included in the range. Another way to look at the range from a graph is to describe every height that our graph touches, because y values are just heights anyway. So let's see if we can describe the domain and range by looking at a few graphs. Let's determine the domain and the range for the graph of the function below. If I want to describe the domain of this function, I need to describe all of the x values that this graph touches or crosses. So if I start on the left side of the graph of this function and trace it to the right side, let's see which x's are touched or crossed by this graph. To determine the domain for this function, I need to focus my eyes on the left and right movement of the graph. The first thing I notice is that the leftmost point of this graph is at -4, and the rightmost point seems to be at +3. So upon initial inspection, it appears that my domain will be all x's from -4 to +3. But I have to inspect the graph a little bit more closely. I have to make sure that every x between -4 and +3 is also touched or crossed. Because the graph of this function is a solid line between x equals -4 and x equals +3, every x value is accounted for between -4 and +3. So that tells me that the domain for this function is -4 to +3 inclusive. And we would write that in interval notation this way. Now let's take a look at the range. Remember, the range is just a list of all the heights that my graph touches. So let's start by finding the lowest y value that is touched by my graph. The lowest point on the graph seems to be at a height of -1. Now let's find the highest point on the graph. The highest point on the graph seems to be at a height of +6. So upon initial inspection, that leads me to believe that my range is from -1 to +6 inclusive. But again, I have to look more closely, and I have to make sure that every height between -1 and +6 is touched by my graph. As I trace my graph from its lowest point to its highest point, I'm able to do so without picking up my pencil or running over any holes in the graph. So that means that every height between -1 and +6 is also included in my range. We would write the range of the function like this. Let's take a look at this graph and determine its domain and range. Let's start with the domain. Again, to do this, I need to describe or list every x value that my graph touches. Upon initial inspection, it looks like the leftmost point of my graph is at about negative 1.75, and the rightmost point is at about positive 1.75. But we have to take into consideration the arrows at the end of the left side and the right side of my graph. The arrow on the left side of my graph tells me that the left side of this graph will continue into infinity in the left direction and the up direction. The arrow on the right side of my graph tells me that this graph will continue forever in the right direction and the up direction. If I know that the graph of this function continues forever in the left direction and continues forever in the right direction, then every x value from negative infinity to positive infinity will be touched by this graph eventually. That means my domain is negative infinity to positive infinity. And we express that in interval notation like this. Now let's talk about the range. Remember, the range is just a description of all the heights that are touched by my graph. Well, as we can see, the lowest height ever touched by my graph is a height of 0. That means that the low end of my range is 0 with brackets around it. The brackets are there because 0 is the lowest height that my graph touches. Now let's talk about the highest height that my graph touches. As we mentioned before, the left arrow and the right arrow tells me that my graph goes forever in the left direction and the right direction. But because the arrows are pointing up, that also tells me that the left side and the right side of this graph also go forever in the up direction. So based on that information, what's the highest height that my graph will ever touch? It never stops going up, so we say that our graph will eventually reach infinity. So infinity is the highest height or the high point of our range. And we always put parentheses around infinity. Let's take a look at this example. This says a relation is graphed below. Give the domain and the range of the relation. In this example, we have 6 individual points that are graphed in the coordinate plane. Let's start by labeling each one of these points. To find the domain of this relation, now that we have the points labeled, all we have to do is list each of the individual x values. And remember, when listing elements of a domain or a range, we never have to repeat elements. So if an element occurs in a domain or a range more than once, we only have to list it once. Now let's list all the elements of the range. Here are all the elements of our range. Let's take a look at this example. This one looks really tough. But if we just stick to what we've already talked about, we'll have no problem finding the domain and the range for this function. Let's start with the domain. It looks like our graph goes no farther left than -6 and no farther right than +5. So upon initial inspection, it looks like my domain might be from -6 to +5. But now we have to look at the interior of our graph from left to right and make sure that every x value between -6 and +5 is touched by our graph. As I start tracing our graph from left to right, beginning at -6, we run into a problem right away. When x is equal to -4, it appears that my graph has a hole in it at the arrow. If a graph has a hole in it, that means that that point of the graph is not included. Another way to say that is that point in the graph does not touch that X or that Y value. So as I begin tracing this graph from left to right, there's a hole at the point -4, 4. So it appears that my graph does not touch the X value of -4. But upon further inspection, I do see that another portion of my graph does touch X equals -4. That's at the point here. That's the point -4, 1. Notice that there's a point here, but that point is closed or filled in. If I see a filled in circle, that means that my graph does touch that point. So far, I've found that my graph touches every X value from -6 to -4. Now let's continue on to the right to make sure that our graph touches every X value from here on out. It looks like every X value from -4 to -2 is touched by my graph. And it looks like every X value from -2 to +1 is touched by my graph. Now some might look at this open point right here when X is equal to 1 and say, well, 1 cannot be included in my domain because there's an open hole. But if we look right above that open hole, when X equals 1, there is a closed hole when X equals 1. So that means that my graph does touch X equals 1. So let's continue on. And as we continue, we see that our graph does indeed touch every X value from X equals 1 to X equals 5. So our domain is every X value from -6 to +5, including -6 and +5. Now let's talk about the range. Upon initial inspection, it looks like the lowest that my graph ever goes is a depth of -1, and it looks like the highest height that's touched by my graph is a height of +4. So that leads me to think that my range might be from -1 to +4. But it's my job to make sure that my graph touches every height between -1 and +4 before I can say definitively that that is my range. So let's see if our graph touches or includes every height from -1 to +4. As we follow our graph up from a depth of -1, the first question that arises is the hole at the point 1, 3. That hole at 1, 3 leads me to believe that 3 might not be included in my range. But looking at other areas of my graph proves otherwise. As we can see, there are two other places on this graph that touch a height of +3. One here and one here. So 3 is included in my range. As we continue up from 3 to 4, it does appear that every height on my graph is touched from 3 to 4. So that tells us that the range of our graph is indeed from -1 to 4 inclusive.